All right, let's look at the homework 4.4, problem number 10. All right, so there's a slight complication of in applying L'Hopital's rule. This is a great example. All right, so let's just give it a try and see what happens. All right, so first, I don't like the square root, so I'm gonna rewrite this part as quantity x squared plus 7 to the 1/2 power. All right, so let's apply. Let's check to see if we can apply L'Hopital's rule. All right, as x approaches infinity, denominator approaches infinity, right, and numerator approaches infinity. So we have infinity over infinity, so we can apply L'Hopital's rule. So applying L'Hopital's rule, we have limit as x approaches infinity, right? So the derivative of x is 1, right? And derivative of the denominator is put 1/2 in front. We have x squared plus 7, raise it to the negative 1/2, and then multiply by derivative inside, which is 2x. So we can simplify. Let's see, so you have a 2 on the bottom and 2 on top, cancel out. So we can rewrite it as limit as x approaches infinity, right? So you have a 1 over, right? So x is going to be on top. So I took care of 1 and took care of x. All right, then we're going to have to put the x squared plus 7 on the bottom because we have a negative power. So you have x squared plus 7 on the bottom. All right, then you have a 1/2 power. So I'm going to actually put the square root back in. So like that. All right. Then, as you can see, it's just a reciprocal. So you're going to end up getting something like this. So limit as x approaches infinity. So you have a square root of x squared plus 7 over x, right? And as you can see, the numerator goes to infinity. So numerator here goes to infinity. And actually, that was a denominator. Sorry, so the numerator goes to infinity. All right, so we can apply L'Hopital's rule again. So, so this is a second application of L'Hopital's rule. So you have limit as x approaches infinity. All right, so we've taken this derivative before. All right, so derivative of square root of x squared plus 7 is x over square root of x squared plus 7 on top, and derivative of x is 1. Right? So if you clean it up, then you have limit as x approaches infinity. So you have x over square root of x squared plus 7. Right? You see something interesting happens. Right? So after the second application of L'Hopital's rule, we went right back to the original limit. So which means that we're going to keep on doing this. So every 2 application of L'Hopital's rule, we're going to go back to the original one. So this is not going to go anywhere. Right? So L'Hopital's rule basically fails in this example. So if that happens, we have to use a different method. So here's how we evaluate it. So if you have a limit, so you have a limit. So here, maybe I would say L'Hopital's rule fails here. All right, then so the way to do this one is the regular way. So you have x over square root of x squared plus 7, right? So what we can do is we're going to try to simplify the denominator as much as possible. So you have x squared is the highest term, but there's a square root, so it's equivalent to x. So I'm going to divide the denominator by x and also divide the numerator by x. right? This will simplify quite a bit here. So you have a limit as x approaches infinity, right? The numerator is going to be x divided by x is going to be 1, right? So here, 1 over x is equivalent to square root of 1 over x squared. So we can just multiply. So inside the square root, we have x squared divided by x squared, so he's going to get 1, and 7 divided by x squared. All right, and this way, as x approaches infinity, 7 over x squared is going to approach 0, and then this is going to approach 1, right? Because it's a 1 over square root of 1, which is 1. All right, so answer is 1, but let's see, what are the choices? So evaluate it, so it's going to be 1, and you cannot apply because the function is not continuous, so that's not the problem. Cannot applicable because the denominator equals 0. No, it's not. Repeated application of L'Hopital's rule result in the original limit, so this is that, or the limit of the reciprocal of the function, so we have that. All right, cannot apply because the numerator equals 0. Nope. You cannot apply L'Hopital's rule because the function is not differentiable. It is differentiable, so we have that. All right, so let's check the answer. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.